Okay, so this is chapter 1.2, solving linear equations. Okay, so by the end of this class, I should be able to solve a linear equation. Okay, remember a linear equation, okay, includes a what? Equal sign, right? There's an equal sign for equation. Okay, now, so the idea we're gonna use here is solving equations. The idea is to what? Isolate the variable, okay, by doing what? The opposite operations. Remember, addition, subtraction is the, opposites, right? And multiplication, divisions are opposites. Okay, so we're going to do the opposite operation to solve, to what? To isolate, okay, the variable in reverse BEDMAS order. Okay, and I'm sure you remember this. So number one, let's try a couple examples. I'm going to go fairly quickly. I don't think I need to spend too much time on this. This is a review. Okay, so for addition subtraction, okay, how do we solve it? Again, most of you can do this probably in your head. You don't even have to rearrange anything. But just for the meantime, I do want you to be able to rearrange stuff. Okay. All right, so how do we solve this? It says to what? To do what? Isolate the variable. So then we want this x by itself. So we want the x to be by itself. Now that means we have to get rid of this negative 2. Okay, so how do we get rid of a negative 2? Okay, you have to do the opposite operation of a minus 2. Well, what's the opposite of minus 2? It's a positive 2 or plus 2. Okay, so what we can do here is a plus 2. However, if you plus 2 on this side, you just imbalance the equation because you added more here on this side. Okay, so you have to add what? 2 on that side too. So whatever you do here, you should do on the other side. So I have to do plus 2 there as well. Okay, so if I do that, negative 2 plus 2 gives me what? 0. So you get x equals to 5 plus 2, which is 7. Okay. All right, remember that? Yes? Review? Okay. Remember I showed you the other way, x minus 2 equals 5. Okay, what we're going to do is take the negative 2 to the other side. Remember, when it jumps the equal sign, it's going to change the opposite operation. The opposite operation is plus. So it's x equals to what? 5 plus 2. Okay, so x equals what? 7. Same thing. You got it? Okay. All right, let's continue, and then let's try another question. So why don't you try this on your own? Okay. All right, so quickly, give you a couple of seconds here. Okay, -1, very good. Okay, so let's go here, watch. So again, we can take this number, which is a positive, to the other side. It becomes a what? A negative. So that means this x equals to 2 minus 3. Okay, so x equals to -1, and you're done. Okay. All right, so let's jump to doing multiplication and division. Okay. So when we have that, I mean, we saw that yesterday here. We had like 2x equals to 6. Okay. What do you have to do here? What do you have to do? Divide both sides by 2. I need to get rid of that 2, okay, because I want to isolate the x. So if I want to get rid of that 2, I divide by 2 on this side. That means I have to divide 2 on this side. Now that crosses out and becomes what? 1. Okay, not 0. Be careful. 1x. Okay, which is what? 3. But 1x is really what? X. We can write 1x as x. So x equals 3. Do you understand? Okay. All right, so let me write another example here, and you can try that. Okay, so negative 2x equals to 8. Okay, and what do you have to divide both sides by this time? Okay, yeah, so you should always divide it by itself, which is negative 2. So divide this side by negative 2, because negative divided by negative gives you a what? Positive. So positive 1, which is just going to be x then. And you end up with what here? Negative 4. Okay, and you're done. Okay, let's take a look at this question right here. This is the division. So remember, if you want to get rid of it, you have to do the what? The opposite operation. Well, this is the division, so I should do a what? Multiplication. Now, that means I have to multiply by, again, itself, which is a 3. So I multiply this one by 3. Again, then I have to multiply this side by 3. Now, again, this becomes then 3 divided by 3. 3 divided by 3 right here equals to 1. 1x is just x, okay, which is then equals to 12. Okay, so what divided by 3 gives you 4? 12. 12 divided by 3 gives you 4. You understand? Okay, let's do the last example for this section, and it's going to be like so. And I taught you how to do this a couple ways, so we can. All right, so look at this here. We want to get rid of the 2 and the 3. I like to get rid of the division first, the fraction first. So it's going to be a multiplication by what? By? Okay, yeah, you could do a negative 3. I'll just leave the negative for later. I multiply by 3. Okay, and I multiply this side by 3 as well. Okay, so that and that reduces to 1, so that's gone. What do you have left here then? Negative 2x equals to 30. Okay, how do you get rid of the negative 2 here? Divide both sides by negative 2. Okay, so that means that x has to equal to what? Negative 15. Okay, did everyone get that? Okay, now I'm going to do it slightly different this time. Okay, and let's see how that works. Whatever you prefer. Okay, I'll do it another way. If you like it this way, you can work on it this way. Okay, let's take a look. So it's negative 2 over 3x equals to 10. Okay. Now, you can think of that as one number. Okay, and that number is being what to x? It's being multiplied to x, right? So if that number is being multiplied to x, that means what I could do is what? Divide both sides by what? Negative 2 over 3. So I could divide both sides by negative 2 over 3. Okay, so I divide this side by negative 2 over 3. Okay, actually, let me write that a little bit differently. Okay, let me write the division a little bit differently so you can see. Okay, so divided by, okay, negative 2 over 3. Okay, so that crosses out, that whole thing crosses out. You're going to get what? X. Okay, now, remember how you do division with fractions. You change that to what? You change the division to what? Multiplication, and you do what with this? You flip it. You take the reciprocal. So it's negative 3 over 2. Okay, so now you get that. 10 times 3 is 30. Divided by 2 is 15. So this is negative 15. Do you understand? So that's another way to do it. Okay. So just to make a note, okay, dividing by a fraction is the same, okay, as multiplying by the what? The reciprocal. Okay, oh, that's got hidden. All right, so let's mix it up a little bit. Okay, so what if we have a combination of things? So what if we have a combination of operations? Again, you have 2x minus 3 equals 5. Okay. And again, what I want to do is isolate the x. That means I have to get rid of the negative 3 here, and I have to get rid of the 2. Which one do I get rid of first, though? The negative 3. Why? That is in the lower order in BEDMAS, right? So you always have to do it in reverse BEDMAS order. Okay, so you have to get rid of the addition subtraction first, then this one, these ones, and then all that. Okay, so you have to get rid of the negative 3 first. Okay, so let's push the negative 3 to the other side. It becomes a what? Positive, so it's plus 3. Okay, so 2x equals what? 8. How do you get rid of the 2? Divide both sides by 2. And so x equals 4. Okay, let's check if it works. 2 times 4 is what? 2 times 4 is 8. Minus 3 is what? 5. Oh, great. Awesome. 5 equals to 5. And that is very true. Okay. All right, let's try one more, and then we'll go to our word problem. Okay, and I want you to try this with a partner or something. Okay. That is a 5. It's kind of slowing down on me now. All right, so let's try to do this. Is negative 3 over 4x. We're pushing this one over. It becomes a what? Positive. So it equals to 10 plus 5. Okay, and then you have negative 3 over 4x equals to 15. Get rid of the 4 by multiplying both sides by 4. So I multiply this side by 4. So those cross out. You get a negative 3x equals to what? 60. So you got 60. And then you divide both sides by negative 3. So divide both sides by negative 3. X equals to negative 20. And that's the end. Yay. So again, this says example 1. Samantha works at a clothing store. She gets paid $50 a week plus 5% commission on the amount that she sells. Now, okay, what are going to be my two variables to model this situation? Okay, let's think about our two quantities. X and Y, what's it going to be? Okay, so Y is going to be the what? Yeah, total she makes. Yeah. Okay, and then X? Yeah, the amount she sells, right? Yeah, I guess what you said was more correct. The amount of the sales, right? In dollars, right? Okay. And this one is in dollars too. So sometimes I like to put my units at the end of the definition there. Okay. So is this a y equals mx plus b type of linear relation, or is that ax plus by equals c? Okay, y equals mx plus c, right? Because it really doesn't make sense for me to combine this y and x together. So it's just going to be what? How much she makes, y, is equal to how much? It says right there somewhere. It says what? $50, okay, plus, okay, 5% of the amount she sells. So what is it going to be? 0.05 times the amount she makes, which is x. Okay, so that's part A. Okay, let's jump to part B now. Okay, and see what we can do. So part B It says, how much does she earn if she sells $500 worth of clothes? Now, you always have to read very carefully and think about what amount did they give me, right? Is it the X amount or is it the Y amount? So $500 worth of clothes. Did they give me the X amount or the Y amount? The X amount, right? That's not how much she earned. That's how much clothes she sold, right? And it was worth $500 worth. You got it? So this is actually the what? The X amount. So that means that X is what? X is equal to now what? 500. You understand? Remember what I said. Letters are just placeholders for values until we know what the value is. In this case, I know that X equals what? 500. Okay. So I write Y. Do I know what Y is now? No. So Y equals 50. Okay. Plus what? 0.05. Do I know what X is? I want to check. Yes, it's 500. So instead of X, I put 500. Okay. And then you solve it. All right, let's solve this. So Y equals 50. And 0.05 of 500 was what? Plus 25. And so if you add those together, you get 75. So therefore, what does this say? What's my conclusion? Therefore, she makes $75 if she sells $500 worth. Okay, C says, how much would she need to sell to earn $100? Again, look at the question carefully and think about the amount that they gave me is part of which variable? Okay, a value for what? A value for X or a value for Y? It's she. How much does she need to sell to earn $100? So that is my Y because that's how much she earns. So Y equals what? $100. Okay. So why don't you sub it in and see what you get? Okay. So Y is 100. So you write 100 is equal to. So instead of Y, I replaced it with 100. Okay. And it's going to be 0.05x. Okay. Plus 50. All right. What do you have to get rid of first again? The 50. So this 50, if I push it to the other side, it becomes a negative. So it's 100 okay, minus 50 is equal to 0.05x. Okay, so that's 50 equals to 0.05x. How do we solve that last part? You divide both sides by 0.05. So X is equal to what? 1,000. Okay. So what is my conclusion? If she wants to make $100, she needs to what? She needs to sell $1,000 worth. Okay, and that's the end of the question.